All right, we're back. Let's take a look at class example number 4. Angle A terminates in the third quadrant with sine equal to -2/3. What is the exact value for each trigonometric ratio for A? So we're looking for a ratio, therefore we need to build a triangle. So I'm going to go ahead and draw a triangle in the third quadrant. And I know that sine is equal to y over r. Now I know the negative has to go with y because r is always positive. So I'm going to put my r here and a 3. And the y is going to be -2. So I'm going to use r squared is equal to x squared plus y squared to find my x value. I'll put a little y over here. And I end up with 9 is equal to x squared plus 4. Subtract 4 from both sides. So x squared is equal to 5. And I take the square root to solve. And we have to consider in quadrant 3, is x going to be positive or negative? Well, if I look where it is, x has to be negative. So I'm going to take the negative square root of 5 as my x value. So each trigonometric ratio, now we already have sine, so I'm going to go ahead and do cosecant really quick. That's going to be -3/2. We're just taking the reciprocal of this guy. And then I'm going to do cosine of A, which is x over r, which is -√5/3, and that's already simplified. And we'll go ahead and do secant of A, which is r over x, which is -3/√5, and I'll go ahead and rationalize that. So I end up with 3√5/5, and there's a negative there. So there's my secant ratio. And I'll do tan up here. Tan theta is that's an A. A is equal to y over x, which is -2/-√5, rationalized. Just erase this so I have more room. And that is equal to these two negatives. A negative divided by a negative is a positive. So I end up with 2√5/5. And then cotan of A is equal to x over y. So that is -√5/-2. And I just got to simplify that by making these both positive. So there we have that one. All right. Class example number 5. Given the point -2, -3 is on the terminal arm of an angle in standard position, determine the measure of angle theta to the nearest tenth. So we're actually looking for the angle here. So our answer needs to end up being an angle. And because the domain is in radians, we're going to express it in radians. So I know that if both x and y are negative, that ends up in quadrant number 3. So I've got x is -2 and y is -3. Now I don't have to go ahead and find r because I'm not looking for the ratios. I'm looking for the angle. So what I'm looking at is which trig ratio uses x and y. If I go to my ratios, I know that's going to be tan. So I'm going to go tan theta is equal to y over x, and they're both negative, but I know that they end up positive because a negative divided by a negative is positive. So now I'm going to find the reference angle, and when you put it into your calculator in radians, There's no exact value, so we can just enter that into our calculator, and my reference angle ends up as 0.9827. I'm not going to round till the end. So to find the rotation angle from there, it's going to be pi plus the rotation angle, or sorry, plus the reference angle. So I end up with theta is equal to pi plus 0.9827 to the nearest tenth. Theta is equal to 4.1 radians. There we go, solved. Let's take a look at class example number 6. If cosecant theta is equal to 7/2, then one approximate measure in radians for theta is. All right, well, I don't like dealing with the reciprocals, so we're going to go ahead and turn that into sine of theta is equal to the reciprocal. So it's 2/7. And if I use my cast rule, I know that sine is positive in quadrant 1 and quadrant 2. I'll go ahead and find the reference angle. Second function sine, 2/7, and that gives me 0.2897. Okay, that answer's not there, so I'm going to look at what the second quadrant solution would be. So that's going to be in radians. It's going to be pi, and then we're going to take away the reference angle, and it'll just give me this piece right here. So theta is equal to pi minus 0.2897. And we end up with 3.431. Question solved. All right, class example number 7. The domain for which secant theta is equal to 3.1 has two solutions is. All right, well, let's take a look. We got to put this as the primary ratio. And now let's take a look at the cast rule. This ratio is positive, and we're dealing with cosine, so I know that cosine is positive in both quadrant 1 and 4. So we would get between 0 and 2 pi, two solutions here. And as you can see, this one, if we just went from pi to 2 pi, do that in a different color so you can see. That would just be this domain here. That would only be one solution. Let's take a look at this one. If I went from pi/2 to 3 pi/2, that would be this domain right here. That would be no solutions. And of course, none of the above, that doesn't apply. So my answer here is A. All right, numerical response number 8. To the nearest tenth of a radian, the value of x for which cotan x is equal to negative 0.25. That's worded a little awkwardly, is. So within this domain, let's take a look. We have tan x is equal to negative 1/0.25. So let's take a look at my cast rule here. I know that tan is negative in quadrant 2 and 4, but if you take a look at the domain, this right here, we're only allowed to respond to answers from pi to 2 pi. So I'm going to have to solve this in quadrant 4. So I'm going to go ahead and find a reference angle. And just a reminder that when you have a negative ratio, when you're looking for the reference angle, you just put it in as positive. So my reference angle, second function tan, 1 over 0.25 in radian mode is 1.3258. And now I'm going to go ahead and find theta. So in quadrant 4, I take 2 pi and I minus my reference angle to find the quadrant 4 angle. So that's going to be 2 pi minus 1.3258, and I end up with 5.0 radians. And I'm going to the nearest tenth as the question asked. All right, next up, your homework.